Hello, and welcome to another episode of The Message from Deep Space. So where we last left off, we were speaking in actual sentences with aliens for the first time. Um, they were talking about themselves, they were talking about the signals, they were talking about where they came from, and they hinted that they were here to do something, and that they want us to do something for them. So they built a meteorite, they sent it from wherever they were, and they moved it 8 to the power of 16. Now, 16 what? We don't know. Um, but they moved it that far. And then it got to us, and now they said, "We sent you a meteorite. Can you send us a meteorite?" And we said, "We will." Um, okay. I'm just so excited here. So first things first. So we're gonna put some words on these. Oh, that's real. You mean we're defining aliens? Dr. Rose, you may be right. Which, of course, means that we are the humans. Okay. Got a groovy new song, too. Okay. So we are starting with negative 47. We're saying negative 47 is a shape. Not a specific shape, just conceptually, it is a shape. Um, so var 0 squared, var 1 squared added equals var 2 squared. So this is a squared plus b squared equals c squared. Repeat. I never did figure out what repeat means. This is. What are my teammates' hypothesis? So, if this is defining a function, this is the function for a circle. I see. So, and then here we see pi, which we know is a relevant number for circles. So we're saying circle var 2 what are we putting this var 2 in parentheses for? Var 3 is pi. So var 2 is so pi r squared is, we go to our geometry, that's the perimeter. Sorry, that's the area. It's right there, and I can't even read. 2 pi r is the perimeter. Okay, so they're defining for us our very first shape. They're saying this is, we have a word for this. A word for a point where you have an equidistant edge from that point. So that word for us would be circle. Circle. They're defining a specific type of shape. Intriguing. I'd wager we'll soon see why. Back to wagering, huh? Oh no, those days are behind me. Okay. Now what do they want us to say about the circle? Okay, so therefore shape 1 equals circle. Okay, oh, this is where they var 2 a squared plus b squared equals c squared. So go back to our geometry. This is the radius. So they're saying that this is a circle. So this syntax, circle parentheses variable, is defining a circle with a given radius, which makes sense. That's the easiest way to define the information about a circle. So here we have var4 and var5 equals 3 exponent 2. So we know that this is always going to be equal to the radius, so we have a radius of 3. Yes, we do. Okay, circle with a radius of 1. And if we define variable 0 as pi, then circle's perimeter is equal to 2 times the radius times pi. In this case, just 2 times pi, because our radius is 1. And our area is equal to pi. Yeah, that makes sense. And if a circle 0's perimeter is 2 rounded 2 sig figs, would be 2 times pi, so 3.14, 6.28, so like 6.3. Okay. Okay. Okay, we have another shape. Statement shape 0 equals circle. No, it doesn't. What do you mean shape 0 equals circles equal something? So shape 0 equals circle. False? Okay, thank you. I like that we can reject something that seems just not correct. So this is labeling the transmission. So this equal circle 3. So set number 0, 0, 0. Then our unknown signal. I don't think circle should new line. So circle 3. Unknown A is circle 3. Set number 0, 0, 0. So we're setting that as an origin. Unknown A 0, 1. Area rounded to 2 sig figs equals 4.2. So if unknown A is still a circle with radius 3, and we pop into our geometry, then we have an area of 9 times pi, or roughly 27. So this doesn't line up. Now, what if it's 1.5? 1.5 squared, maybe they're defining a diameter? So if we go to our calculator and we do 1.5 squared and 2.25. No, because 2.25 times pi still gets us at least 6. So unknown A is 0. Now we used this notation earlier to indicate that we were creating a circle. So we have circle 3 Now, it's interesting that we number the unknown A here when we don't number it here. So, not 100% sure what's up with that. Okay, why do you define circle like this here? So, let's see. If we go to our transmissions, and we look at our previous ones, then circle 0. Okay, so this is how we indicate that we're talking about a specific circle. So we have circle 0, and here we have circle 3. Nothing else, we're already starting at 3. Now, we don't do anything with this set number, which is part of why I'm really confused. So these coordinates at the origin are separate from these. So we want the area 2, area rounded to 2 sig figs. Are we getting 3 circles? 4.2 feels like a number. Okay, well, you know what? If we know the area, we should be able to determine the perimeter. So let's work from that. If we take our calculator and we do 4.2 by 3.1415. Okay, so we have, because it's pi r squared. So if we divide by pi, we now have r squared. So we need the square root of this number. Do we have a? We don't have a square root finder. Okay, let's work backwards a little bit. So let's see. I think in theory I should be able to use log to find the square root. Do we have that in the math reference? Square roots. Square root, and the square root of a number is the number raised to the power of 1/2. Okay, so I can just do to the power of 1/2. So we go back to our calculator. And we raise this to the power of 0.5. We have our square root. And if we take this and we do... give that back. We multiply this times 2. This should be our radius. And then we do this times pi. Okay, I really hope that this works out. Then we get 7.3. No? Yes. No? What are you asking then? Why do you give us these coordinates? Okay, unknown A. Unknown A equals circle 3. So if unknown A 0 1 area rounded to 2 sig figs. Okay, 7.3 feels right, but it must not be. Well, I am gonna pop open Desmos. See if that helps at all. So, okay. If we do 4.2 divided by pi, we take the square root of that. And then we take that number times 2. And just to be sure, 2 times pi times r. Within 2 sig figs would be 7.3. We're gonna try 7.2 just in case we round down. Okay, so we're not rounding here. This is a real stumper. Okay. Unknown A zeros. 1 as a perimeter. Now, maybe it's not a circle. So maybe we're saying circle with 3 sides. No. This is why they gave us the coordinate. Because that's a coordinate in 3-dimensional space. So they're saying a circle in 3 dimensions. Oh my god. It's so obvious. It's actually so obvious. So 3D geometry. So the unit sphere should have 4/3 times pi times 1. So I'm guessing that 4/3, so 1.33 times 3.14 gets to about 4.2. Yes, it does. Okay, that makes sense. Okay, so 4 times pi is going to be 12.56, so 12.6. Nope. Okay. Okay. Then we're gonna do just 12. Oh, it's right. Of course, it's just 12 because it's gonna be 13. Because rounding up significant figures. Oh. Okay. We know what this is. That's a sphere. 3D circle? Sure. Sphere works. Okay. Okay. So var 0 squared, var 1 squared. So if we add a squared plus b squared plus c squared equals d squared, is that in line for a sphere? I feel like that is the equation for a sphere. Yes, it is. Yes, it is. Okay, a sphere. So sphere 0 has a radius of 2 and an area rounded to 2 sig figs. So okay, so this is copying the unit value. So we need 4 over 3 times 2, no, times pi times, I guess we could multiply this by 4, by 8. Does that work? I guess I don't see why it wouldn't work. Times 8. So this is going to be 33 and something. I'm assuming the perimeter for the same sphere. Yes. Reference, math, 3D geometry. So we're going to take this, we're going to plop that into the calculator, and we're going to multiply it by 4. All right, so that's 33 and 50 for our volume and our surface area. No. Why not? What did I do wrong? Okay, I was so confident in that. So back over to the geometry. And then back over to the calculator. Must have gotten a mistake here. Or I'm wrong. Ah. I have to remember to round up. I keep wanting to truncate significant figures instead of rounding them. Okay. So a sphere with a radius of 3 taken as the area of 3. Okay. What? Okay, so a sphere with a radius of 3. If we calculate the area and take that to 3 significant figures, and we go to a sphere with a radius of 3, and the perimeter rounded to 3 significant figures. Why is this being presented as an equation? Why does that first one have an equals when the second one needs something to be solved for? Okay, well, let's answer the question that they're asking us. So let's grab the perimeter equation and let's go to the calculator, paste that in, and then multiply times 9. Are they equal? I guess they are equal. And no, they're not. 3 significant figures. 33.5. No, that's not it either. What are you getting at here? All right, I'm gonna see what my coworkers think. No, not this one. Okay. Yeah, okay. Ah, I see. They're entrusting us to define the innards of a statement ourselves. I don't know if you can trust me with this. Um, okay. Responsibilities are growing. And how does that make you feel? It's a challenge for sure, but the great Dr. Alan Akers has never been known to shy away from challenges. You regret asking him? Yep. I thought that was a nice answer, Akers. Okay, let's see. How were they defining this? So the perimeter, they say equal to this, which is fine and dandy. That's how we answered it, though. Oh, you know what? I guess we're being asked two questions. So we have 33.5, and we also will have the the volume. So take the volume equation and put it in the calculator. Multiply this by 3 cubed, which is 27, and multiply these, get our volume, and reduce this down to our 3 sig figs, and hope that they like it this way. Nope. Okay. How would they format this? They might do and. No. What do you mean 113 and? Those are separate. Why would you combine them? Uh. Oh, we replaced and with a comma. No? Okay. I don't know if I 100% understand the syntax it's asking for here. So just to be sure I've got this right, I am going to pull, let's see, okay. We were geometry. Okay, we have 4 over 3 times pi times our radius cubed, and then we have our radius, we have 4 times pi times our radius squared. And we have a value of 3. I think I had this wrong. I think that I forgot to square the output, duh, of the radius for the surface area. So I guess let's see if they just want 113, because these are the same number. They do just want 113. Okay, we got a transmission grouping. Circles and spheres. Alright, 3 new signals. 3 new signals at once is pretty big. It might be a record. Okay. So, unknown A. Unknown B. Unknown C. The very rarely seen unknown C. Unknown A is equal to var 0. Unknown B is equal to var 1. Unknown C is equal to var 2. set 1 or set 0 is a 3D point at 148. So this is a sequence of squares. Um, set 0 unknown b equals 4. Set 0 unknown c. So set 0 unknown a is equal to 1. So it's 8. Oh, okay. I thought that they were giving us first, second, and third at first. At first, yeah. Uh, but I don't think that's what they're doing here. I think they're giving us X, Y, and Z as coordinate planes. So X, Y, Z. The first spatial dimension. That works. No, clean? Come on, Bautista, it's only one character long. Not feeling it. Maybe later. Uh, okay, but what do you have to say about Y? Is Y clean? Hey, Bautista, it's only one character long. I see. Dr. Rose entered Y. Come on, buddy, you know you wanna. Nope. Not even on Z? Come on. Bautista, you said maybe later. Now is later. Hmm. Z. Hmm. Okay. I admit. Clean. Yeah! Happy to make Bautista happy. Okay. So, we have a shape consisting of 4 set numbers. The shape is 0. The set number count is 8. I see the ellipsis here. So, shape 0, 0, 0, 0. Shape 0, X. Ooh, we gotta fix the formatting on these. It's dire. One day I'll stop hitting X all the time instead of back. Okay, let's see if that looks any better. So X var, Y var, Z var. Shape 0 var count equals. Are they so? They're asking us probably for the distinct number of points. Is that what they're doing here? I am not. Okay, so they are asking us what dimension the space is in. So here we have 2, X or Y or Z, shape 0. So set number X. Yeah. So on a 2D plane, we're agreeing to use X and Y. On a 3D plane, we are agreeing to use X, Y, and Z. Okay. Shape 0. Set numbers. 4 set numbers. 4 more set numbers with specific coordinates. These will make a square, or they will make a rectangle. And shape 0, X distance, so the length of the X side is 2, and the length of the Y side is 6. Straightforward enough. Okay, very easy. Circle var count equals 2, so we're in we have a 2D circle. So circle, and it wants me to initiate a circle. So I don't know. 1? No. Okay. It wants me to do something more complicated than that. So if our var count is 2, can we just say xy? Is that crazy? I guess it's not crazy. Okay, so I understand that we have to agree on like a commonality here, but this just feels like we're already on the same page. Okay, so a sphere with an area, and XYZ, and a sphere. Okay, so this is saying that we are using an area here instead of a radius, or I guess a volume. So sphere 0 at, let's see, has an area of 1 at 0, 0, 0. Sphere 1 has an area of 3 at 1, 2, 0. And sphere 2 has an area of 5 at 2, 4, 0. Sphere 3 has an area of 7. Okay. And it wants me to continue the pattern. So this is increasing by 1, this is increasing by 2, this is not increasing. So we follow the trend, back to counting, sphere 4. 4, 8, 0. Sphere 4, parentheses, 9. 4, 8, 0. Okay, I mean, I don't know why we did that, but it worked. Okay, sphere 0, 1, negative 1, negative 1. Why are we defining spheres in the shape of a cube? Sphere 0. Okay, so now we are using these to draw essentially a cube like this. The question is why? There's, okay, sphere 0, 1. Okay, so we need to find the missing corner. So let's see. Sphere 0, negative 1, negative 1, negative 1. So 0, negative 1, negative 1, and 1. So let's go ahead and use this as our center. So negative 1, negative 1, 1, 1, negative 1, 1, negative 1. It's 2 back there. And then negative 1, 1, 1. That's 3. Are we missing all positive ones? I think we're missing all positive ones. All right. I love extrapolating information. Yeah. That's a big number. Okay, so sphere 0, which has a radius of 1,836. position 0, 0. Sphere 1, which has a radius of 1, is 4,096 away. So, sphere 1, move. Sphere 1, move. Sphere 1, move. Larger than or smaller than sphere 1. Answer this. Sphere 2. So, we want to know if sphere 1 is larger than sphere 0. Obviously not. So, you can see here that we're moving sphere 1. Doesn't matter if you move it, it'll never be larger than. So, sphere 1 is smaller than. Okay. So, new word. Okay, unknown A. Repeat guess. Sphere equals unknown A. So, the repeated process of using or making a sphere results in unknown A. And then it's asking us to confirm. Are we learning about hyperspheres? I don't know if I'm ready for 4D geometry. Repeat sphere 0. Therefore, sphere 0 equals unknown A. Okay. Doesn't really help. Oh, we got a new word and we're not ready for it. Okay. Shit. I feel like it's the first time we've gone to a new word while we still have a previous word not yet defined. Okay, unknown B. Unknown B, var 0, where var 0 is greater than -1 and var 0 is less than 65. Now, keeping in mind that 64 is 100, then that means that this is a positive number between 0 and 100. So I don't know what to do with that. We're gonna define this as pause between 0 and I'm out of characters. Pause 0 100. I don't. It's such a clunky definition, but because it's probably not 2 digits, because 2 digits we could do with we couldn't do with sig figs. Now if we repeatedly draw a sphere, that gives us motion. So I wonder if maybe that's what they were getting at with this one. Let's see. I'm gonna put a little tag on the end there so we can keep track of what's going on with that. Okay, but in the meantime, 0 equals 0, easy peasy. unknown A motion, XYZ, area, position between positive between 0 and 100. Repeat, sphere 0. What the heck is happening? With a radius, var3, at position -1, 12, and 8.5. And sphere 0, positive 0 to 100 equals 32. Okay, so fully, I guess I just didn't understand what was happening. Because this doesn't make sense. Okay. So, if we did something with variable 0, the variable 0 must be greater than -1 and must be less than 65. So this could instead be unknown A. How did you use this before? You've never put anything in the parenthetical after this motion question before. Okay. We have unknown A motion up here as an example. So we have XYZ, area, and position 0 to 100. Now, here we have sphere 0, unknown A motion, something. Some function of a sphere. So sphere 0, var3, these three here. Sphere 0. Okay, where are we getting 32 from? Oh. Okay. Okay. What do you make of this? We could always copy what they gave us. Say X, Y, Z, area, unknown A. That's not, they didn't give us unknown A. They gave us the between 0 and 100. I mean, I don't like it. I kind of hope this doesn't work. Okay. So we know that repeating a sphere is the equivalent of an unknown A. So here we have that is our position. We have some number and sphere 0 with a positive 0 to 100 value of 32 and area equal to var3. Okay. So that would make this, if we fill these in, -1, 12, and 8.5. Okay, and then we have area and a position 0 to 100. We have our position 0 to 100. Keep saying position. Positive value between 0 and 100. This is 32. And an area of var3. Do we define var3 anywhere? Area. Right, so this is how we were doing our radius. So we need to know what radius causes this to equal 32. And so area equals var3. No, we don't know how these relate. But can we just say var3? What if we just left it at that? Okay, yeah. So they wanted us to fill that out. God knows why. What did we group that under? Placing spheres. Yeah. That is, I kind of got that. So we're being told x, y, 0 and area is our sphere, like position for a sphere. So this is the position, the area of the sphere, and then some value between 0 and 100. But what value? What? But why? All we know is it has to be between 0 and 100. Okay. Okay. Unknown B. Unknown B repeating is motion. Answer this. 0 equals 0. Yep. Oh, I'm so in over my head. Oh no. Oh no. Oh no. Unknown A. Okay, so our count of unknown A equals something to solve. Unknown B, so we have motion 1 0 0 1 0. Unknown A, motion -1 0 0 1 0. So we have our XYZ, our area, and then something that we don't know. But we have 1, 2, 3, 4, 5, 6 of them. And I can tell you that we have 6 of them. I don't know why that matters, but that is what you were asking for. What are you trying to tell me? Okay, so collection 0 is unknown A. Okay, we know we know that it's not, that it's, we know something about it. So it doesn't feel like we should just keep calling it unknown A. Let's call this like sphere at. I don't love it, but it's something. So sphere at 0, sphere at 1, sphere at 2. Collection 1 is 3 spheres at different locations, 4 spheres at different locations. Collection 0 is smaller than collection 1, and then now, okay. Does any of this matter? Because by my count, this is saying that we have a series of sphere definitions, no number associated with them, in random places. I don't know what to do with that. But I can tell you that the collection in 0 is 3 spheres, and the collection in 1 is 4 spheres. And 4 is larger than 1. So, or 4 is smaller or larger than 3. So 3 is smaller than 4. No, it's not that simple. Ah, shucks. Guess it's the other one. I was really pulling for smaller than 2. I don't want to just say that, though. It's okay. Larger than. Okay, I used bigger than instead of larger than. We don't have synonyms here. Why? Oh no. Oh no, we've ended the week and we truly don't know what some of these words mean. Truly no idea. Where's Bautista? Didn't he call this meeting? I think to get rid of us. What? I wouldn't put it like that, but yes, Dr. Bautista said it was best we cleared the room. Why didn't we get to make that call? Are you all working on the translation? Yeah, you tell him, boss. Just a moment, Dr. Doppler. He's doing so in our best interest. He said he needed us to step away so he could program something. And he did say if we didn't have some new program, it would be difficult to continue. This better not be another confetti situation. Confetti? What are we talking about? Shh, don't tell him about our confetti. Now wait, what is this about confetti? We cracked the alien's language. I'm listening. Alan, tell me how. We learned to communicate what a sphere is with sphere. And you use that to learn how to master energy in intergalactic travel? We're getting there. Dr. Akers may be overplaying our progress. Yeah, I was starting to realize that. Regardless, I trust Bautista's working hard. I think even if he wasn't paid, he'd want to be here on the computer. Maybe I could save some budget there. Yeah, you could give a salary to me. Nah, never mind. Hey, Dr. Rose, are we having some clarity on the transmission we discussed last week? We haven't seen aliens or humans again, so we have nothing new with which we can proceed. Let me know if that changes. Now, let's head home. Good night, team. Good night, Dup. Sweet dreams, everyone. I wonder what Dr. Bautista's working on. I wonder if it's some sort of visualizer, so we can actually see what's going on with these spheres. Okay. Uh, I, I, I don't like seeing unknown B and pause 0 100 here. That makes me feel very uncertain about what's to come. Um, Alan's journal. Status good. Was kind of hoping I could get a trophy this week, though. I didn't really do anything to stand out. Dop didn't even give one out at all. Bautista's log. Carrie's diary. Dear diary, it was surprisingly mundane this week for how climactic last week's transmissions appeared. Perhaps I've missed some of the subtext of the latest transmissions, or perhaps it's merely building to a new peak. Doppler's report. Still never found out what confetti was all about. Sounds mischievous. Uh, these transmissions are the first to be really confounding, even after we get more examples. I hope we solve them quick. Next week. All right. Yeah, they also know what sphere and circle mean, but not a very good guess about the other two. Um, so, oh, that is so many numbers. Um, it looks like we do have a visualizer. That will be very, very exciting next week. Uh, so I'm gonna go ahead and end there. But if you enjoyed, don't forget to like and subscribe, and I will see you in the next one. Bye!